Python to concepts that we discussed briefly in semester one, just as a review for everyone in case you're still having some questions about like just the fundamentals of Python coding. So I'll be talking about things like variables, if statements, functions, loops. And so if you feel comfortable implementing those ideas, then feel free to drop out of the lecture. But if you still have questions about those Python fundamentals, maybe when you see them in the lab notebooks or the homebook notebooks, then stick around and we can do a quick review of them. So if you want, you can follow along with what I'm doing on Replit. I'll be showing like a series of problems which you can code for yourself. But if not, you can just look at what I'm doing and you can ask questions and discuss. Yeah, so can you see my screen, Rachel?
Yep, this is perfect.
Cool. Okay, so yeah, I just made a quick list of what we'll discuss in this review. I'm aiming for something like 20 minutes to 30 minutes, so I might go a little bit over. Sorry about that. So once again, if you have questions about these basic Python concepts, then stick around and we can have a good discussion on them. But if not, feel free to drop out. So yeah, I'll be talking about variables, lists, if statements, for loops, and then finally functions. These are all ideas that we've been seeing repeatedly whenever we code using Qiskit. And so this is meant to be just a quick review so that you can get more comfortable with everything that we do in the labs and homeworks. So I'll give people maybe 30 seconds if you want to fire up your Replit to follow along, and then I'll begin. To answer a couple of the questions, this review is not yet available on Canvas. I will post the completed notebook on Canvas afterwards. And we are just reviewing Python, not Qiskit, in this session. Okay, so I'm going to begin. And Rachel, maybe you can pass along some questions to me as they come up in the chat or the Q&A. So let me begin by just talking about variables, right, which are what we use to store different data values in Python. And there isn't a specific command, there isn't a specific way that you like declare a variable in Python. You just like give it a value and that creates your variable. And the way that you give it a value is just by using the equals sign. So if you just say variable equals some value, that is just going to generate your variable for you. So I have a quick question, which you guys can code along with me. So I want you to create two variables. That should be a 2, not a 3. Sorry. So I want you to create two variables, one called name, which just stores your name, and another one called bit, which just stores either a 0 or a 1. You can pick either a 0 or a 1. Okay. And then I want you to just print the sentence. The value of your name's bit is, and then print the value of the bit. So that's the coding task that I want you guys to try to do. So to repeat, I just want you to create a variable called name, which stores your name in it. Then I want you to create another variable called bit, which just stores either a 0 or a 1. You can pick your favorite one. And then just print the sentence. The value of your name's bit is, and then print the bit value. So I'll pause for maybe a minute to let you guys figure this out. If you want, you can send me your code through the Q&A. You can try the coding on Replit. If you're using like PyCharm or Jupyter for coding, you can also use that. Up to you. Or you can just follow along with what I'm doing right now and ask your questions. All right, so I'll give you 30 more seconds to try this out. So two variables, name and bit, and then print the sentence that's on the screen. All right, let's try this out. So I want to create these two variables. So what I'm going to do first is I'm just going to say name equals Akshay. The reason I need to include that Akshay inside double quotes is just because Akshay is a word, and usually in Python, when you want to store a word inside a variable, you have to enclose it in double quotes. These words in Python are called strings. So Akshay is stored as a string. And then I can say bit equals 0. I would just like to use 0 here. You can use your favorite bit. Okay. And then to print, we just use print the value of, and then if you want to print more than one thing, the way we do that is we just use plus. So plus name so now that's, and then in quotes, bit is, and then once again, I'm going to add a plus, and then I'm going to say bit. Okay. Let's run that and see what happens. Okay, so I got an error. Can anyone tell me, like, why didn't this work? Why did this not work? You can answer in the Q&A. Why did this not work? Oh, yeah, thank you for that suggestion. I'm just enlarging my screen here. Rachel, did that actually zoom in? I just want to check.
Yes, it did.
Okay, cool. Yep, so a lot of you are saying that the problem here is that the bit, this bit that I'm printing, right, it's a number. And in Python, you can't just use this format to print strings and numbers at the same time. So what I need to do is I need to convert my bit into a string. And so you do that by just using this str, and then you put in the bit in brackets. And if I then print it, and then it prints the value of Akshay's bit is 0. So this is how we create and we can print variables. Any questions on this before we move on? Next, I'll be talking about lists. So any questions on variables, on printing and things like this? Rahul, I will be sharing this notebook after the lecture. We'll put it up on Canvas. Does it understand space? Yes, it does. So you'll notice that I put a space at the end of off. So yes, it does. Okay, I'm not seeing any questions related to this. I'm going to move on to lists. So lists are what we use to store multiple values at the same time. So you will have noticed that in those variables I declared up in my code, I could just store like one bit or one name. We use lists to store multiple numbers or multiple names in the same variable. The way we make lists is by using square brackets. And you have seen lists already, right? We saw lists last week when we were doing quantum key distribution. We were storing the qubits that Alice is sending Bob as a list. So we have seen lists already. And the way that you can access any one element in a list is you use its index number. And indices in Python begin with 0. So the first element of the list is index 0. The second one is index 1, and so on. So here's a second question, which you guys can again start coding in Replit or whatever you're using. I want you to create a list, which is called mylist, and store the names of all the quantum gates you can think of. We've been spending a lot of time now looking at the different quantum gates. So I want you to create a list called mylist and just store all the different quantum gates that you can think of inside that list. And then once you've created that list and stored all the different gates, I would like you to print the whole list, the length of the list, how many elements there are in the list, and finally I want you to print the fifth element of this list. So if you start counting from the start of the list, right, you have one first element, second, third, fourth, and I want you to print the fifth one. So I'll give you guys maybe a minute and then we'll code together. And as usual, you can just keep on sending me any questions you might have in the Q&A. So yeah, just try creating this list. You'll use square brackets to create it. And then try printing the whole list, then the length of that list, and finally try printing the fifth element of that list. Pablo, I'm hoping to finish the review in another 15 to 20 minutes, but it is going to be recorded, so you can check out the recording later. Okay, maybe 20 more seconds, and then we'll start coding. I like, Hemant, I like your list. Yeah, you guys can feel free to send me your code in the Q&A. Okay, so let's try coding this. I'm going to create a variable called myList, and I'm going to say that is equal to square brackets. We use square brackets to create lists. And then let's see, xgate, ygate, zgate, hgate, c0 gate. What else? Rx gate. Thank you, Javier, for that suggestion. Rx gate. Right. We can keep going. I'm just going to end my list here, but obviously we can keep on including more and more gates here. So that's the list. I included each of them in quotes because once again, these are all words, right? So I would just like to have them in quotes. Okay, then I'm going to print the whole list. So just print my list, and that's going to print my whole list. Then I'm going to say print, and now I want to find the length of this list, and the function we use for that is len, L-E-N, and then my list. And that's going to tell me how many entries there are in my list. And then finally, print my list. And then to specify a specific term, we use square brackets, and then we can enter the index of that term. And so here I want the fifth element. But remember, these indices start at 0. And so I'm going to print my list 4, which is going to print the fifth element. So let's run that. And so we get that we printed out the entire list. This tells me that the length of my list is 6. So let's just double check. 1, 2, 3, 4, 5, 6. Yep. And then finally, this is telling me that the fifth element is C0. So let's just check that. First, second, third, fourth, fifth. So indeed, the fifth element is C0. Okay, any questions on lists? Just basic handling of lists. How do you create them? How do you print different elements before we move on? Amol, I'd recommend reviewing the NumPy labs that we did at the beginning of the semester, because I think that in those labs we discussed matrix multiplications as well as how do you define vectors, etc. So I would recommend reviewing those labs. Okay, so I'm not seeing any questions. So I'm going to move on. And now we're going to be talking about control flows, loops, and if statements. So once you have defined these variables or lists, right, often it's very useful to compare them with each other, to make decisions based on if one thing is bigger than or smaller than another thing. So that's what we mean by control. You can control what your code is doing based on some comparison that you make. And the way you make comparisons in Python is you can make different kinds of comparisons by using different these different operators. So equals, you just use the double equals operator. Not equals, you use exclamation mark equals. Less than equal to, greater than equal to. So those are pretty self-explanatory and why those look the way they do. As a quick question, can someone in the Q&A tell me, why don't we use A equals B for the equals comparison? If you want to compare if A and B are equal, why don't we just say A equals B for that check? Why is that like a double equal sign here? Yeah, exactly. So a lot of you are saying in the chat that if you just do A equals B, right, what that's going to do is it's going to give A the value of B. It's not going to compare them. So to explicitly say that you're comparing them, we are using these two equal signs. Okay, so let's use our knowledge of these comparisons to now talk about how do you use them to make decisions in your code. Okay, so that's what we mean by an if statement. You can use if statements to use these comparisons and make decisions. So an if statement is going to perform an action if only if a certain condition is true. If it's false, then whatever action you've told your code to perform will not be performed. And we just use the keyword if to write if statements. And you can also use if statements to test multiple conditions sequentially, one after the other. And we use this construct of if, else if, or elif, and we can add another else if, and so on, and finally an else. And one really important thing to remember here is that the indentation must be correct. So in other programming languages that you guys might have seen, other languages use like parentheses or something to separate different bits of code. In Python, we use indentation. So if you want to include some code inside an if statement, it must be indented. And I'll show you what you mean when we do. I'll show you what I mean when I do some coding in just a moment. So here's a question that I want you guys to try to implement using an if statement. So I want you to create two variables, A and B, and they both store a bit value. So both A and B can store either 0 or 1. So for example, A and B could be the results of a classical measurement on a 2-qubit quantum circuit, right? When you measure a 2-qubit quantum circuit, in both of the bits, you're going to get either a 0 or a 1. And then I want you to print A is greater than B if A is greater than B. I want you to print A is equal to B if A is equal to B. And I want you to print A is less than B if A is less than B. So here's here's an example of where an if statement can be really useful. Okay, so I'll give you guys a minute or maybe 2 minutes to think about this, and then we'll start coding. And once again, you can just send me your code in the Q&A, as well as any questions that you have. So Claire asks, do we need end commands? So I'm assuming you mean, do we need to write an end when the if statement is done? So it turns out that you don't, and I'll show you that when I start coding. But again, in Python, the way that we show where an if statement or a loop or a function begins and ends is just by using indentation. So wherever you change indentation, wherever you switch back to the old indentation you were using, that's when the compiler will know that your function or your if statement is over. I'll show you what I mean in just a minute when I start coding. All right, so I'll wait for 30 more seconds. You can continue sending me your code, and then I'll start coding. Vedant asks, why are we not learning while loop? It's a great question. I think the choice between for loops and while loops is often a choice of style. And I like using for loops, but you can totally also use while loops. You can do everything that you can do with a for loop with a while loop and vice versa. I just prefer using for loops. Okay, so I'm going to start. So what we want to do is we want to create a variable a, and I want to assign it a bit value. So I'm just going to say that a is 1, and then I'm going to say that b is 0, right? I just randomly chose those values. Then I'm going to say if, because I want to make a decision, if a is greater than b. And whenever you have these kinds of statements, you have to put a colon to indicate that you're now going to put in code which talks about what to do in case this if statement is true. You're going to start a different level of indentation. So if a is greater than b, we're going to say print a is greater than b, right? Else, and then I want to continue adding conditions. I'm going to say else if a is equal to b. So now I'm checking the case if a is equal to b. We're going to say print a is equal to b. Okay. And then finally, the only condition left is that a is less than b. So you don't need to explicitly write that. Even you can just use an else statement. So print a is less than b. And to answer your question, wait, I don't see the question anymore. Oops. Where is it?
I think it was, what's the difference between else, elif and else?
Right, okay, yes. So what is the difference between else if and else, right? So else if is used when you still want to give it a condition. So notice that here I used a equals b. So I'm still making a comparison. Else is used when you've just run out of conditions and you just want to be like, okay, if none of these previous ones are true, here's what I want you to do. So you don't give any conditions with else. You're just saying if nothing else is true, here's what I want to happen. Okay, so let's run that. And so because a is 1 and b is 0, it executed the first one. So it just printed a is greater than b. If I change these values, if I say instead that a is 1 and b is also 1, then now it's printing that a is equal to b. And finally, if I change a to 0, now it's saying that a is less than b. So what happened in this case is it first checked the first if statement, and that was not true because a is not greater than b. It then checked the second if statement, which is also not true because a is not equal to b. And so it just came onto the last else statement. And it printed out, it did whatever was said in that statement. Why can't you just replace an else if with an if? That's a great question. You can. So I can do this. And it's still going to work. The difference is that in this case, it's going to make two comparisons. It's going to first check this, and then it's also going to check this. Whereas if I do this, if I do an else if, it's only going to make one of these three comparisons. It's only going to make this one, and if this is true, it's going to skip the else if. Whereas if I just do this, it's going to make this comparison, and then it's also going to make this comparison, regardless of whether or not this first one is true. Whereas if I have an else if this first one is true, it's going to skip this else if. So that's the difference. Elif is just, I think, Python format, like Python's way of writing else if. Other languages use the whole word else if. Python, I think, just uses elif. Okay. Other questions about conditionals before we move on to loops? For loops? Could I explain how to do indenting? Yes, actually, I actually meant to do that and then I forgot. So you'll notice here that this print statement, that's indented. That's it's not starting right on the left here. There's like a bit of a gap here. And most Python development tools will do this indenting for you automatically. And if you don't do this indenting, so for example, if I just do this, right? This gives me an error because it says expected and indented block. It's expecting you to indent it. And if you don't do it, it's not going to run because now Python doesn't know what goes inside your if statement and what doesn't. So indenting is really, really important. Whenever you want to change the level of indenting, what you can do is just press tab, and that's going to do it for you. And as I said, most of these softwares will just automatically do the indenting for you. You'll also notice that the if, the else if, and the else, those are all at the same level of indent. So don't change the indentation between the if, the else if, and the else. That could be one error that some of you might be getting. Okay, let's keep moving. Now let's talk about loops. So a loop is something that you use when you want to run the same piece of code again and again, or if you want to analyze the different elements in a list one by one, right? This is something that we saw in the QKD lab last week when we analyzed each bit of Alice and Bob's keys one by one, right? When we did that, we used a for loop to go over the bits one by one. So we use loops when we want to run a piece of code repeatedly, or if we want to go over the elements of a list one by one. A for loop, it's called a for loop because it just uses the word for, and a while loop, which I'm not going to do today, but it's called that because it uses the word while. When you define a loop, a very useful function is this function called range. And what range is going to do is it's going to return a sequence of numbers. So something like, let's say, let me do a quick example of that. So, sorry, I'm going to have to shrink back out to add another cell. So something like print range 5, right? That's just, oops. Or if I say something like a equals range 5, and then I say print a, right? It's, I'm somehow not able to get it to print. But what this is going to do is it's going to create numbers from 0, 1, 2, 3, 4, 5. It's going to create numbers in that range. And so that's very useful when you're.
I think you can convert it if you do list around range.
Thank you.
Because range is itself an iterator. Oh, or list like LIST.
Oh, to convert it
to a type. Okay. Yeah.
Okay, there we go. Thank you, Brian.
No worries.
Yeah. So yeah, this is just very useful for generating ranges of numbers so that you can then iterate, or you can then use those to go over your lists one by one. So we are going to be using the range function quite a bit. And if you look at the notebooks that we did in labs in the last 2 or 3 weeks, you will see this function used repeatedly. Okay, So to practice loops, okay, Claire asks, why does it not include 5 in the list? That's just, I think, a decision that the people who made that function made. So yeah, when you use range, it does not include that last element. So it's going to be 0, 1, 2, 3, 4, up until like the element that you include minus 1. Okay, so here's a question that you guys can think about. So Alice and Bob have been using QKD to build their keys. They're not very good at QKD yet, but they're just figuring it out. They're trying to get used to it. They're trying to do some QKD to distribute keys between them. And the length of the keys is 8 bits. Okay, they've decided to use an 8-bit key. Alice's key is 00110001. That's Alice's key. And Bob's key is 0010001. So I've given you values for Bob's keys. And so what Alice and Bob want to do is they want to make sure that their keys match. And so what I want you to do is just write a very simple piece of code in which you'll go over each bit of Alice and Bob's keys one by one and see if those bits match. And print if the bit matches or if it doesn't match. So let me repeat. Alice and Bob have these 2 keys that they've generated using QKD, which they're not yet very good at. And they want to compare their keys because they're just learning, they're figuring out QKD. So they want to see if they successfully did it. And so I want you to store their keys in 2 variables, Alice key and Bob key. And then I want you to compare their keys element by element and print if each bit matches or if it doesn't. Iris, yes, range returns natural numbers. There are other functions that you can use to return decimals. I'm not going to get into that here, but feel free to Google around and find functions that do the things that you want to do. So I'm going to pause for maybe another minute and let you guys code this, and then we'll code it together. Once again, you can send me your code in the Q&A as you develop it, and any questions. Okay, so I'm going to start coding this. So first, I want to define a variable called Alice key, and we're going to say that that is, let's see, what did I decide here? It is 0, 0, 0, 1, 1, 0, 0, 0, 1. Okay. Then I'm going to create another variable called Bob key, which is 0, 0, 1, 0, 0, 0, 0, 1. Okay, just checking if the lengths are the same. Now I can use a for loop to compare these keys. So I'm going to say for I in range 8, right? The length of their keys is 8 bits. So for I in range 8, I want I to go from 0, 1, 2, 3, 4, 5, 6, 7. We're going to say, oops. And then once again, you have to use a colon sign to then indicate that you're starting off with what's going to go inside the for loop. So it automatically created an indentation for me. If Alice key at the index I is the same as Bob key at the index I, we're going to say print the bits at index match. So in this case, if the bits are equal, they match. Else, we're going to just say print the bits at index do not match. And so here you'll notice that I converted the I to a string. Again, same issue as before. If we don't do this, it won't print correctly. Okay, let's run this. Okay, so it tells us that the bits at index 0 match, 1, 2, at index 3, they do not match. 4, 5, 6, 7, all of those match. So we were able to use this for loop to compare each of these bits one by one. And now imagine how much work this would have been if we hadn't been using this loop, if we had done it manually for each bit one at a time. So for loops are used to reduce the amount of code that you need to write. We were able to do this with just like 5 lines of code instead of having a separate comparison for every bit. And here we only have 8 bits, right? But I could expand this to like 100 bits and the code length would remain the same if we use loops. What does I represent, Victor asks? So I is the variable that I'm using to go over to represent each index of the keys. So you'll notice that I said if Alice underscore key at the index I is equal to Bob's index, Bob key at the index I. So I is being used to represent the index that's currently being compared. I is going to go from 0 to 7. That's what we represented when we said range 8. It's going to take I from 0 to 7. Okay, any questions about loops before we move on to our last topic, which is functions? How come 3 does not match? That's just because of the way that I defined this. We can change this, so I could instead do like this. So now I just change Bob key to 0011, and now they all match. So that's just, that's just how I define them. This, for example, this could be exactly, so Fran was discussing last week, right? Alice and Bob are going to compare the first few bits of their keys to check if there's an eavesdropper. So they could exactly implement this piece of code. And if their bits start not matching, they know that there's an eavesdropper present. So one of the challenge problems for last week's lab was to implement the code for an eavesdropper. And this is this could be a bit of that code, is to check the first few bits of your key. And if they don't match, then you know that someone was eavesdropping. Okay, a couple of you are asking questions about like if there's more than one loop, you can totally like put loops inside loops. So then you can use different, so you would use like I for the outer loop and J for an inner loop. You can totally do that kind of nesting. It's called nesting, and you can totally do that. I won't be doing examples of that here, but yes, that's totally allowed. Okay, let's move on to our last topic, which is functions. So a function is a block of code which you can call at specific times in your whenever you're writing your program. So if there's a bit of code that you want to call at a specific time, you want to run that piece of code at a specific time, and also you want that piece of code to behave differently depending on what input you give it, then you can put that bit of code inside a function. So you guys might have come across functions when you study math, right? We use f of x to represent functions. So this is a very, very similar idea. You give it an input and it produces some kind of output. And depending on what input you give, the output changes. The most common way that we use functions is we put in some code inside the function that we know we'll need to use later on. And then we can call that function or use that function to implement that piece of code. Enrique, to answer your question, yes, it's the same if you use a list. In Python, strings and lists are treated very, very similarly. So you can use a list also. We've already been using a lot of functions. So the print command that you've been using, that's a function. And whatever you give it inside the parentheses, that is the input that you're giving to the print. In previous labs, you've also used functions like input or compile. execute. You've used the execute function to run quantum circuits. You've used the quantum circuit function to create quantum circuits. So these are all examples of functions. And you can define your own functions as well. The way you do that is you use this keyword called def, D-E-F. So def followed by the name of your function. So here I'm just calling it my function. And then you have to put parentheses to explicitly state that it is a function. And this is a very simple function. It just prints hello from keyboard. So if you run this code block, that's just going to define the function. So there's two steps to using functions. First, you have to define it, and then you have to call it. So just defining the function is not enough. You have to call your function. So that's what is happening here. We are calling our function. And the way you do that is you just type the name of your function and then parentheses, and that just calls your function. And when I call it, it just prints hello from keyboard. So it's only when you call your function that you actually use it in your code. And that's what makes functions so useful, is you can just set aside that piece of code by defining it, and then you can call it exactly when you want to use it. So as I was saying, functions can be given inputs, right, to make them behave differently depending on what the input is. And those inputs are also called arguments. So argument and input, they mean the same thing. And you put them inside the parentheses. So notice that this function did not take any inputs. But if you want to give it an input, you can just put it inside those parentheses. When you use the print statement, right, this is the input. We're putting that input inside parentheses. So that's the input to the print statement. Okay, so here's the final question for our little programming review. I wanted to create a function that's going to compare Alice and Bob's keys that we had just done in the previous question. So I wanted to create a function which will compare Alice and Bob's keys, and then I want you to call that function and compare two specific examples of compare a specific example of Alice and Bob's keys. So up here, we had already implemented this comparison. Now I just wanted to create a function which you can just call to make this comparison for you. This would be really useful, right? Because what this would mean is that you don't need to keep on writing this code over and over. Whenever you want to make a comparison, you just call this function. Whenever Alice and Bob want to check if there's an eavesdropper, they'll just use this function. Okay, so I'll wait for maybe a minute. I know that we're running a bit long. I apologize for that. But we are almost done. I'll wait for a minute. You guys can send me your code, or you can wait for me to start coding. So yeah, all that we're doing here is just creating a function which does the same comparison that we had done previously. You can call the function whatever you want. Give it your favorite name. Aris asks, we always create functions before the main function, right? So we don't use main functions in Python as far as I know. I think that's more of a C++ or C. That's how C++ and C are written usually. In Python, I don't believe that we use main functions. You can certainly call functions from other functions. You can totally do that. But you don't need to create main functions in Python the way that you might in C++ or C.
Oh, Akshay, I might be interpreting wrong, but I think the student might be asking in terms of ordering of functions. Like if it matters if you call, maybe not, but this might be a good thing to discuss if you call a function that's defined after, like.
Oh, I see what you mean. Okay. Thanks for clarifying that, Fran. So yes, you always have to define the function before you call it. That needs to happen. But what you can do is if you have a code block where you're defining several functions, then the order inside that does not matter. So you can define different functions in whatever order you want, as long as the function is defined before you're calling it. That is in fact a very common mistake that I make when I'm coding, is I'll either like call a function, but I would not have run the code block where it was defined, or the code block where it's defined is like later on in my code. So yeah, you always need to define your function before you call it. Okay, let's start coding this. So I'm going to call my function compare. I'm going to borrow Javier's name. And now I want my function to take two inputs. I want it to take Alice's key, and I want it to take Bob's key, because I want my function to behave differently depending on what these keys are, right? I want it to print the bit-by-bit comparison of the specific keys that I want to give it. So just like loops and if statements, you have to end this statement with a colon, again, to specify that you've now entered the part where you're going to type out the code that goes inside the function. Okay, then I'm just going to copy the code that I had over here, because it's the same code. So I'm just going to copy this code over. One small change I'm going to make is instead of writing for I in range 8, I'm just going to say for I in range length of Alice key. So what this does is it just makes our function a bit more general. Now this function can compare keys of any length, not necessarily 8. Okay. And that's all there is to it. If you just run this block, oops, there was a problem. Ah, right, there was a problem with the indentation because I didn't indent the if statement correctly. So I'm just going to change this indentation there, because when you enter the for loop, I hadn't indented my if statement correctly. And now it's defined. And now I'm going to define Alice's key. So let's say Alice key is equal to 001. Bob key is equal to 010. I'm just using a short key. And then let's call the function. So compare Alice key, comma, Bob key. So in this statement, I'm calling my function. I'm using my function. And the advantage of giving it these inputs is that now I can change these keys and I don't need to retype everything. And so this is now telling me that for these keys, the bits at index 0 match, at 1 they don't, and at 2 they don't. And now if I change this to, let's say, 0001010, and let's make sure the lengths are the same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's add another one. This, I was able to use the same function without having to make any changes to compare this second key. I could have used length of Bob. That's completely fair. One kind of shortcoming of my function right now is that the lengths of the two keys have to be the same. But I could have totally used the length of either one. Are variables inside a function local to that function? Yes, they are. What if the length of the keys is not the same? Then you could modify the function to account for that. You can build in some fail safes against it. Yeah. Why did the arguments have the same name as variables? Yes, I agree that that is a little bit confusing. So what you could do instead is, if you want to avoid that confusion, you can give them different names. So what you could do is you can just say A, comma B. And then you have to change it consistently everywhere. I'm just calling it Alice and Bob A and B. And this will still work. Still works. So yeah, if you want to avoid that confusion, you can totally use different names. You can also use the same names. That also works. So that's kind of a style choice. noise.
Hey Akshay, not to put you on the spot, but maybe to relate this back to today's lecture, do you think you could tell us the big O of your compare function?
The big O of the compare function. So let's think about that. How many operations is the compare function performing? So what we are doing here is we are comparing each bit one at a time, right? And each comparison is one operation, right? For every bit, we are saying, make that comparison. And so as we increase the number of bits, I think that we are linearly increasing the number of operations. If we have 3 keys, if we have 3 bits, we are making 3 operations. If we have 10 bits, we are making 10 comparisons or 10 operations. And so I think that the big O of this function is order n. It should be scaling linearly.
Awesome. Thanks, Akshay. Just
Yep,
another example for everyone.
Yep. And I'm seeing a lot of students in the chat are also replying order n. All right, so I think that's pretty much all that I had planned. This was just a gentle reminder review of these basic concepts, and hopefully everyone feels a little bit more confident about um, seeing functions and loops and if statements used in the lab and homework notebooks. Definitely feel free to send us more questions on Piazza as they come up, and we will share this notebook on Canvas.
Thanks, Akshay. Have a great rest of your weekend, everyone.
All right, bye everyone. See you all in labs.